Colby, math.com.
We spent some time today on integer operations. We focused on multiplying and dividing integers and understanding why those rules work the way they do. We'll also get a little bit of integer subtraction with this example, so that should be helpful for some of you if this is an area where you struggle. We have an algebraic expression b multiplied by the difference of a and c, and we've been given variable values, and so we'll simply use the substitution property and substitute into this expression. B is positive 3, so 3 multiplied by the difference of a and c. A is negative 2, and we're subtracting c, which is negative 7. So we're multiplying 3 by this difference, and so we need to find the difference before we do any multiplication. And the difference of two integers, it's often helpful to rewrite this as an addition expression, because it's hard to think about what's happening when you're subtracting negative 7. You may have learned keep, change, where you keep the first number, change this to addition, and then change the subtrahend to its opposite. I prefer to talk about the definition of subtraction, which is simply that subtracting is the same as adding the opposite. And so I'm going to rewrite this subtraction expression as addition by again saying that subtracting is the same as adding the opposite of whatever we were subtracting, and the opposite of negative 7 is positive 7. And then at that point, you know, if you're having trouble with integer addition, there's different ways to think about it. You could think about money like negative 2 is like owing somebody $2. And then if you gained $7, you could pay them back the $2 that you owed them, and you'd still have $5. So negative 2 plus 7 is 5. You could also use an open number line. And so you put your starting number, negative 2, on a number line. And 0 might be here. And then if we're starting at negative 2 and we're adding positive 7, then we're going 7 to the right. But we need to go 2 to the right just to get to 0. So that means we'll go 5 more to the right to land at that sum, which is positive 5. So now we have 3 multiplied by positive 5. A positive multiplied by positive is positive. I'm also going to do one of the problems on the back with you, just to make sure the directions are clear on this one. For problems 12 through 17, use the number line pictured below to complete the comparisons by filling in each oval with less than, equal to, or greater than. And so we have all of these numbers represented by the variables a, b, c, d, and e. This is 0. This is the origin. And you can assign reasonable values to each of these numbers. For example, d is to the right of 0, so maybe it's positive 2. E might be positive 4. C might be negative 2. B might be negative 4. And A might be negative 5. But you don't even need to really assign values. You just need to know which ones are negative. The ones to the left are negative, and the ones to the right of the origin are positive. Then when you substitute in whether they're positive or negative into these expressions, for example, e divided by a, I'll be taking a positive dividend and dividing it by a, which is a negative divisor, and think about what your quotient would be, positive or negative, based on the rules we learned today. Do the same thing on the right side. For e divided by d, figure out whether your quotient would be positive or negative, and then fill in that oval during the pause and come back and see how you did.
Paused.
For e divided by d, we have a positive divided by a positive. And if you have a positive dividend and a positive divisor, you'll always have a positive quotient. Over here we had a positive dividend and a negative divisor. That will give you a negative quotient. And so without even knowing what the quotients are, if you're comparing a negative number to a positive number, this comparison will be less than. I hope that helped. I'll see you tomorrow.